I'm joined today by Salim Dabbous, the Director of Digital Technical Consulting at SICK, a global leader in sensing technology, as we discuss the right mix of people and products for certain situations. Salim, thank you so much for joining us here today for Control Automation Day. I'm really excited to learn from you about the experiences that you've had and the guidance that you have for our audience. When we start these discussions, we always like to get to know the presenter just a little bit first. So could you give us just a little bit about your educational background and really what got you interested in automation and industrial equipment in the first place?
Hi, David. Happy to be here. Thanks for having me. I'm looking forward for this as well. So a little bit of background. I studied electrical engineering, and then I chose the uh, technology path, and I'm very happy that I chose that track because it was hands-on. It was we had labs settings, and we had like a lot of hands-on when it gets to applying all the theories and everything else we were studying about. So that was a good starting point for me. And then during that program, we were introduced to a couple courses around PLCs, and that's what was interesting. I had no clue that I'll be getting into that domain and that space, but shortly after I graduated, I landed an opportunity up in Detroit, and as you know, it's the Motor City, so there's a lot of automotive, a lot of automation. That's where I started, and that journey continued to be in that space. After that, I can tell you throughout the discussion, there was a pivot point where I wanted to move out of the hands-on and the controls, program, because that becomes, it sticks with you. And then I wanted just to grow out of it a little bit. And then I went in and did my master's in program and project management.
That's a great, well-rounded background, being able to bring
Thank
in the hands-on part. I know that's a very common thing for engineers, and both mechanical and electrical side. It seems like that PLC content kind of brings together some mechanical programs have a PLC mechatronics element and electrical as well. And then to
Absolutely.
add on top of that, the project management, which sort of brings in a perspective that's different than many engineers have, is really valuable. What about your involvement with organizations that are kind of outside of just the industry, maybe those that are more involved for education or for outreach for these kind of technologies? As the future generation continues to, these jobs are certainly going to be in demand, and they're changing all the time. So being able to create education and awareness, we feel, especially here at Control.com, being huge on education. What's your background with those kind of organizations?
Yeah, absolutely. So after been working in that space, there's always this interest. It's a personal interest that I wanted to always learn new things and be on the front end of like learning new technologies and migrating what we have and adopting that. And within my organization, we have the luxury to work in with not just with our partners and our customers, we also work with educational sectors as well. So we have a team that works directly with some universities, and I had the opportunities to be involved in some of these programs. And there was some universities that took that to the next level, where they introduced like an advanced manufacturing programs, where they extended their settings from just the typical labs. They actually expanded that to introduce and to add in real applications. So if it's okay, there's like the University of Alabama here in Tuscaloosa, they extended this program. There's the state itself in Alabama, has seen a lot of growth when it gets to automotive. There was a lot of demand for uh, advanced manufacturing engineers. So they figured that if they couple, the education part with hands-on, and it makes a big difference. So it kind of preps and gets the engineers or future engineers ready So Mercedes had teamed up with that program. They kind of provided some real robots, some mini assembly lines, if you would. So they have this space where you walk in. It's beyond the lab. It's a real cell, fenced in with safety equipment and all this, and it just it gives you the real perspective and real hands-on. And there's a few other programs that we are engaged with. So with universities. So it's definitely a plus, and I'm happy to see that going because these future engineers they get to see it and then decide whether or not that's a track they want to proceed versus waiting till they graduate and finding out that it's not necessarily
Absolutely.
what they like to do. Yeah.
And I know that what you're saying about SICK's involvement with education, I've actually been able to work with some of your colleagues that work with educational outreach and some of my connections with schools, and being able to provide some of those resources to even community colleges and high schools has been just tremendous partnership and willingness to work with schools. And so I really appreciate SICK for that.
Absolutely. Yeah.
So moving a little bit more now, let's get a little bit more to the technical side. Our discussion topic of the day, our whole theme of the Control Automation Day is about sensors. But this discussion is going to be a little bit of a fun twist, because we're going to spend some time, of course, talking about technology, but also a lot of time talking about people, the people that are involved in the journey of technology as well. It's nice to be able to talk about sensors, but we also have to be able to talk about what sensors do and how they fit with the advancement of these things like digital transformation and IIoT, which we'll talk again about in a minute. But right before we get into that, could you give us just maybe a little bit of an update of sensor technology in recent times? Is it more of advancements in the hardware of sensor technology, the software analytics of sensor technology? Where are some kind of the biggest leaps and bounds of research taking place right now?
Yeah, that's a good question, David. I would say uh, it's a little bit of both. It's the hardware itself, and keeping up with technology and introducing new features and add-ons, and I'll specify a little bit more on that. And then the software part to be able to enable and take these parameters and new functions and interact or interface with pre-existing platforms, and or now introducing the digital platforms. And we hear a lot about digital transformation and IIoT and all of that. So I would say it's both. You would need first, there's some existing data and parameters within the equipment and within the sensors and the devices that exist. Whether or not they're being tapped onto or not, that's different, right? You might have a sensor that has a lot of capabilities, but it's just used for on-off kind of a process, and that's okay. It provides what's required, but then there's a lot more within, like the health diagnostics. There's a lot more to learn and to get out of these sensors, and that's where the right now we need a little bit more content, a little bit more data sets to help us do more analysis, do more predictions, if you would. So it's both. Some of the challenges I would say more on the these are not commodities, right? Now you're talking introducing new communication, uh, you know, protocols and the likes, but it's working its way out slowly but surely.
And I think probably a very visible example of what you're talking about is, it seems like IO-Link is being installed into so many different devices and systems just to facilitate that. Great if we can just get that on-off signal, but if we can get more data, then which I guess kind of brings up a second important question is that what engineers are looking for right now as a majority of the customer base? Is it sensors with more functionality, or sensors that have the same functions as they used to, but with better speed, better precision, longer distances, easier configuration? What's kind of the trend? It's kind of that multi-functions versus doing that one function really, really well.
Right now, let's use condition monitoring or condition-based monitoring as an example, right? Um, that one, there's a trend in the automation and also in the automotive sector. What we're seeing there in that regard is on existing machines or existing motors, if we were to pick up and do the live monitoring for these motors and help reduce or even better eliminate downtime, so we can proactively, find out about a motor setting. In those cases, it's introducing new sensors because you don't want to tap on or jeopardize anything that's already working. The sensor that's already in place and the triggers and the dynamics, that's all, it's doing a pretty good job and it's keeping up the process. In that case, it's introducing a new technology that doesn't disrupt or interfere with anything that you have existing. So you would need something that's fast, reliable, that can get you live, data sets, and then be able to adapt it. It needs to be flexible so it can adapt to interface with existing platforms like PLCs and on the control level, and then also with the ERP system, the MES, and with IT, without putting any burden on the network, without impacting the process. So uh, uh, that's where we were doing a series of these applications, and it's we always have to reassure that production and maintenance that this is a read only and it doesn't impact. This can go down. We can lose a connectivity to a sensor, or if the device is not communicating, it will not disrupt or impact you at all with your existing machineries. If that's on the legacy machines, right, on brown fields. I would say for green fields, now there's nothing. Actually, it will be even better to use that same sensor that can do the processing, right? It's can be IO link, and it can give us the on-off signal, and in parallel, it can give us the additional parameters. It can still be segregated. That sensor would still work to provide functionality, and everything else would be an add-on for live monitoring and further analysis.
So that greenfield kind of situation gives them much more open access to designing what's going to give them the process data that they need, but also the analytics data that they need, and accomplish that without having those two separate networks.
100%. Yes. Yeah.
Yeah, and that completely makes sense. It sounds like when we talk about something that can provide lots of data accurately, not disrupt the network, there's so many variables there that I can understand why it would be a bit of an intimidation to somebody who's not familiar with this process. Where do we get started? That sounds too good to be true, but it also sounds too difficult to implement easily. And I guess that's why we're having this discussion today, is what are those steps required to even begin that adventure? Because this is much more complicated than just installing a new sensor.
Yeah. Yeah. Absolutely. It's a matter of understanding the customer and our partners. They know their layouts and machines the best. It comes down to finding that use case, right? And looking at what they have, and we always use what's existing. That's always the first stepping point. That data, it might be already existing, it resides, but it's probably inside a particular controller, a PLC, or a particular sensor. So starting with that, and then growing it and having the mindset of uh, being able to adapt eventually to extend that onto additional data sets. That's when you introduce new sensors, then you start introducing gateways. It's uh, it needs both. You need the customer, and the team who understand and know the processes in and out, coupled with a technology or solution provider who can bring that solution, and it has to be relevant to their application, and then roll it out.
Yeah, and we'll dive into the specifics of who those team players look like. But really quickly before we do that, I know we use a lot of words like digital transformation, IIoT, and those can certainly they can fit a broad range of different types of projects, and people who've done this for years are familiar with what that entails. But could you give us just a little bit of very specific, tangible, we talked about the condition monitoring example. I think that's probably one of the most common that people hear about. Are there maybe just a couple of things where they can kind of get the gears turning of when we use the word digital transformation or the IIoT, what kind of specific things could a person say, oh, in my facility, we're dealing with that challenge. This is what it means to me. Just a couple of, I realize there's many examples in this case, but just those ones as we're getting started that people can kind of keep in the back of their mind during our discussion.
Yeah, absolutely. So as you know, David, we hear about digital transformation, we hear about smart manufacturing, IIoT, Industry 4.0, digital twin, right? It's all, I mean, a lot of it can be also buzzwords, and it can mean, something different to others. It's very important to align, in the beginning at what is that definition, and to your question, how does that relate to a particular application or to an organization, right? So it is the integration of technologies, right? Getting digital devices, sensors, gateways, controllers, all interact, and integrated together. That's great. But it's not only that, it's also it's a mindset and a culture change, and being open to adopt new technology, not just for the sake of changing, but actually for a better use. And when they digitalize on a process and streamline a process for communication, getting data, now you're turning that data into information. Now you're being able to make sense out of that readily available data, or maybe with a little bit of add-ons. Now you can predict, you can rather than react, right? That's the normal mode. Like, we have a failure, then we have to go and do something about it. Think of it like, if we can proactively work up front, and if we're able to tell you, you got to do something about this particular machine, we're seeing some anomalies, and go do something about that, then it's a game changer, right? It's a mindset, right? It's a mindset, being open to that, and then leveraging all of this between technology and the understanding and adopting these new functions to be able to help and support the organization digitally, and how they transaction, and also how they deal with their customers. Condition monitoring is a common one. I think that falls in nicely. Under that, there's also a series of condition monitoring. Like, there's the live motor monitoring, there's energy monitoring, compressed air monitoring is another one. In parallel, we're seeing a lot of need for vision systems that can pick up certain things, and anything you can see with your eye, it can be replicated, and it can be automated, right? So introducing those technologies, right, with like 3D vision is a big one, and then applying machine learning on top of this technology to be able to navigate and then help operators with inspection, and then free up to do maybe better things. So it's having that understanding. We spend a lot of time on that front end with our customers and partners to make sure we have a common language and a common understanding. What is that? Where's the ROI, and are they ready? Because you need the buy-in from operator level all the way through to management, and that message need to come across, and it need to sit and to be adopted. So only then you can be successful with whatever you're introducing in that regard.
Well, that's a perfect segue into our next point, because now as we kind of get down into more specifics of this team, obviously the first step of any project, and I'm sure digital transformation is no different, the first step is not starting to buy hardware or starting to install a new program. The first step is bringing together the right people that can think of what is needed, what is going to be the best advantage for us to get started. And so if
Absolutely.
that team is just in that forming stage, beginning to get built, what would be kind of a logical selection of the right people to bring? Too many, I'm sure, is not favorable, but too few and not enough information about the project can also be a bit of a disadvantage. What do you find most commonly from the projects that you work with? What are the people that are in the room when those discussions are first happening?
You're absolutely right. Having the team and building the team up front is absolutely crucial and important to this. Um, the successful in best practice so far, it's a combination of, with our experience, is somebody with controls background and understanding, right? Coupled with a automation or a process engineer that knows, understands the process and have a need in for analytics and getting more visualization and even better like remedies. So those two primarily, of course, they need to be supported by their management. So and have that, common goals on digital transformation. And then the third representative would be from IT. We like to introduce IT at least in the beginning, not necessarily in every step along the way, but just to kind of inform them that, hey, we are working on this proof of concept or on this pilot or demo, and there would be a need at some point to expand this, right, and have more interface with IT. So if we do that early on, especially with IT, one, they'll have an appreciation of, getting pulled in and awareness of what's going on, because we need to tap onto the network at some point. You are supported and have the controls engineer, someone with that's open to new technologies, and they want to think also outside of the PLC, because we've experienced some that say they think and they would challenge that, oh, why can't we can do everything in the PLC? Yes, true, but now you're adding a burden on it. So somebody with that open-minded to extend beyond the PLC and are faced with more with IT. And then I mentioned the process engineer. He or she would be the one that given us uh, the process data, the what's relevant for them, what's a good dashboard look like, what type of trends and analysis they want to see, so they can optimize the process. We've had, some good success with having alignment among these teams, and working closely with them, and after deployment we would be able to move on to the next steps and rolling it out if that's what they desire.
This keynote is sponsored by SICK. SICK Sensor Intelligence is redefining automation. From smart factories to logistics, our cutting-edge sensors deliver precision, reliability, and real-time insights. Empower your operations with intelligent sensing solutions that drive innovation, efficiency, and safety. SICK, where technology meets tomorrow's possibilities. Something that you've mentioned a couple of times now is not somebody who's an expert in all things digital transformation, but somebody who's open-minded. Maybe that's a burden for some people, or what they think is a burden is, well, I don't know a lot about this. Maybe I'm not the right choice. But the right choice is not necessarily the expert. It's the person who's open to saying, how can we improve this? How can we make it better?
It's very interesting you say this, David, because there's no one person that know it all, honestly, especially with this, with the speed with where technology is going, with everything that's changing. And as we said before, it's not a commodity. It's not like a PLC. You come in and you program, and then you follow the process or the sequence of operation, and it works. It's way beyond that. You need to interface with IT. You need to understand communication protocols that's are out there. And you're absolutely right. You don't have to be an expert on all these things. However, you need to bring in, these experts and it's okay to ask all these questions and figure it out, together. Some customers, they have dedicated teams, and they'll tell us like, oh, just show me how the product was and I'll take it from there. Okay, good. But it just um, we get it. They can deliver, but it comes with a higher price, because those people they want to, and there's nothing wrong with that. It's just doing it the hard way. They want to, they are passionate to learn these new things, and they like to do it themselves. It's a mindset. Uh, so we equip them, we help them, we train them, we show them what it's like, and then they do they work on that first application, second application, but then when they're ready to roll it out, they come back and say, okay, let's work together, help us out, let's see how we can, because they won't have the capacity to keep up with it. But at that point, they are, have more expertise with it and feel much more comfortable, and they're satisfied, their passion, and they've learned it. So sometimes we are faced with these requests, and that's okay.
So there's another kind of a side angle here that you mentioned machine learning a little while ago, and maybe that sort of parallels another really common term is AI. Is that something that you find that to begin this journey, does there need to be some fundamental foundation amount of knowledge about AI? Or for most of these simple introductory pilot projects, does that really not enter the equation yet until there starts being much larger data sets and cloud connectivity? Where does and how does that AI discussion fit into this for these new pilot projects?
It's a step up approach. We definitely don't lead or start with introducing AI, in the beginning, unless the customer is already at a point with their digital transformation where they're ready for it. The only time is when we engage in that discussion. However, it's like building blocks, and it's a milestone, right? First, you need to get your connectivity figured out. You get the proper sensors, you get the technology around it, the gateways, the controllers, all of the above. Figure out the connectivity part, coupled with the visualization, the notification, and dashboard, which is, someone can say, oh, this is pretty typical. This is what we do with HMI, rightfully so. And beyond that, now we start getting into the analysis and doing the certain trends and figuring out what good is, where anomalies are, and start to prompt these. And at that point, we can start talking about AI, and even better, instead of, because AI can be intimidating to some customers, especially when they start linking to security reasons, privacy, and there's a lot of things that ties to it. So what we do, and these are customers that are quite ready to that point. So what we do, we take a step back and say, it's not, at this point, it's not necessarily AI. It's truly machine learning. We have the connectivity figured out. Now we're getting reliable data. Now we want to understand the machine and see how it's operating. And this is doing machine learning, applying algorithms, and defining those normal states. And that's where you need the intelligence and the know-how from the process engineering. And what helps is, now we're working together, and then they see at that point where it's machine related, it has nothing to do with the product, right? And that's where it just the other conversations come in, and the customers want to put in particular NDAs, and they got their legal teams involved, and it takes a lot of time because it's a new thing. And then now the fear is, now you're tapping onto the product itself. However, it's a fine line, David, and that needs to be highlighted. Otherwise, it can stop the project and kind of voids it. So what we do is and that's important to engage IT, right? To tell them, okay, this is a parallel streaming, and this is the data that we're getting. It's machine relevant data. It's not product data. You know what I mean? And it takes a lot of time and reassurance. But if we say AI, it just kind of it puts a lot of people, makes them uncomfortable. So we have to kind of step
Absolutely.
it down and kind of get it back to reality and explain to them what does it really look like and show them reality and factuals rather than just uh, scare them off with AI.
It's one of those especially difficult things because it's hard to even identify what exactly is AI, before you can even begin to imagine how it can be implemented. And I guess that makes it even more important to understand that every project, every company is different. So being able to ask all these questions from the very beginning, what do we
Yeah.
need to accomplish? What is the end goal of this? Before we start saying yes or no, we will use this element, we won't use this element, we will use these sensors or this software. We have to discuss what the project is and what the outcomes with the ROI are going to be. What KPIs do we want to meet before even beginning that discussion of what's going to be involved?
Exactly. And having these early conversations, it's a door opener, right? And you're having a discussion where uh, we have alignment on what's the application look like, what parameters we're trying to get to. And then once the hardware is identified, to your point, now we need to put it in the IT's hand and in the engineering hand so they can work with it and make sure that it's compatible and they can it's added to their project books and meets the specs. So these are the things we want to do early on. And once we have these approvals, now we can see it in action and in real time. And then they can start rolling it out when they're ready to scale up.
Speaking of all those additional the projects, the existing software, those kind of things, is from the stage of getting started with a pilot project, is from a hardware and software perspective particularly, do these sorts of projects integrate with platforms that are already in existence, like for example, SCADA platforms like FactoryTalk, Aviva, Ignition, whatever customers might have in their facility? Do these projects usually involve some connection with those existing platforms, or like the hardware, are these often off to the side and never involved with the existing system?
So if the customer if they are set up with these existing platforms that have some sort of, like you mentioned, SCADA systems and beyond the PLC, we often um, work with them on the front end to make sure that we can interface with their existing platform. That's the number one thing. We exhaust what they have because that data might reside within the PLC, right? And the customer might choose. It depends where they at with that on the HMI side of things. They might have some powerful analytics and readily available softwares that can take on these new parameters. At that point, we would engage with them and make sure that we have the interface figured out, and then we are able to tap onto these existing parameters. It's all dependent on their readiness, right? Where they at in that stage in time. We have customers who have applications that are sitting in an island sort of thing that's not interfacing or interconnected with anything, and those we will it will be simply just the using the sensor, the gateways, our digital solution coupled with a our analytics. We have a field analytics software that can it's an enabler at this point. Should they not have any of these HMIs or analysis, we can tie it all together and provide them that local visualization. And then once that's all proven, then we start looking at, okay, where they want that data to be stored, what are we gonna interface. So it's always dependent on their maturity level of the equipment, and then what's next, where they're stepping it up to the next upgrade or where they want to take it next.
Yeah, and I guess maybe a point about this that we should have made from the very beginning is, most of what you're saying is general terms and not apply to every situation. And each one is going to be obviously quite unique, but some of these are just looking at, in general, what are the common factors, what are some of the common things, and continuing right off of that. Commonly, not all the time, but when it comes to actually doing the work, the implementation of the hardware, the integration with a platform, is that usually done by that in-house team, those engineers that you mentioned, or by the equipment manufacturer like SICK, or do you usually bring in an integrator to be able to work with the company to accomplish those actual installation steps?
Yeah, on the if we're doing like a pilot or demonstration, like on a small scale, oftentimes the customer themselves, they have either their own maintenance team, right? It's if we're talking just like couple, or handful of applications, they often have the teams and they want to see it firsthand, so they offer their team to do the installation. So we from our side, from the SICK team, we help them on guidance, like where to mount it, how to do the orientation for these particular sensors, ensure that we're following the standards when it gets to cable length, and certain limitations when it gets to IO length, like the 20 meter, for example, sensor to gateway, and things like that. So we help them, we guide them through it, and oftentimes we're able to pull it off just on that scale. Beyond that, we start uh, you know uh, we start talking with third-party integrators to come in and do the actual installation for electrical and mechanical. And oftentimes we take that on as a prime, and we provide a turnkey. So we work. Customer might have a preference to work with a local, integrator or general contractor that they work with, and we'll use that as a sub, and then we provide the overall turnkey project.
When you're doing these small initial installations, is that a process that's somewhat forgiving? Like, obviously you would always recommend that people look ahead to say, if this is successful, we
Yeah.
want to be able to scale this up in the future, but we don't think about all of that right now. We just think about what's going to best prepare us for that level of when it comes time to scale up, which we'll talk about in just a second. But at this point, if mistakes are made, perhaps the wrong data is being collected along the line, or there was an element that we hadn't considered. Is the pilot project fairly forgiving, or do you find that if people make mistakes in the process, or are there certain mistakes that can really be a major hindrance that people should be aware of?
No, that's an excellent point. Actually, we use that pilot on that small scale to figure out all of these things, because this is not a predefined process. Like you're producing, this car or this product. Everything is predefined, everything is nailed down and prototyped and all this. This is a completely different uh, process. It is there's a lot there's a series of unknown, right? Give you a quick example. We have one of our sensors, we calling it multi-physics box, because it provides multiple parameters. It provides vibration, it provides temperature and shock, right? And within each one of those, with as you know, vibration has a lot of layers, and there's cortosis and the VRMS, the RMS. There's a lot of different parameters. That one sensor, that tiny sensor, you're looking like it's lightweight. It provides all these different parameters. It's capable to produce over 150 parameters. Okay, so that we had one of the customers said they're interested in every single parameter, and we're like, well, so we had to doing something like this as a pilot, and we said, all right, we pass this data through, but too much data can be as bad as no data if we're not doing anything with it, right? It will start diluting your trends, your graphs, and the analysis. So we have to be specific. Fast forward with that particular application through the pilot, we managed to trim down, all these parameters to like 12, maybe 15. So those were the most required parameters. And still 15 data sets from one sensor is quite a bit.
Still quite a bit.
But yeah, so we had to, and initially we were passing all that data, and something's gonna give, right? It started overloading the network. It started like you're just passing a lot of data and can be overlooked. So doing something like a pilot at that point, we get okay, 30 to 90 days. We're doing a lot of learning. We're learning the process. The customer is learning about the technology. It's a joint effort. It allows everybody to come back and flex and adopt, whether it's parameter settings, um, you know, uh, agree and align on communication protocols, where that data is gonna land, right? Is it locally? Is it uh, somewhere on with IT? Is it cloud based with on premise? It allows for all these discussions, and you need that period of time because all these are uh, classified as unknowns, and as we go through, we start figuring it out. Now, the best part would be during that phase if we start finding or running into some of these anomalies. Now, seeing is believing. Now we start saying, okay, well, this is good. This motor or this application or this camera system is providing this and this and this. It's an anomaly. It opens up, it's a mindset change, and we start getting to the core. Uh, we had it before. If we were to jump to it, it will only extend the time, and people will be uncomfortable, and so it is. There's a lot of flexibility, and it is forgiving to a greater extent because you're kind of redefining things as you go before they uh, satisfied with it and ready to move on to the next phase.
Speaking of that, moving on to the next phase, I guess that's what people say when they say scaling up. We use that term all the
Yes.
time with IIoT kinds of projects. And something that
Yeah.
I've always been curious about is certainly people will say, well, once it's proved success and then it's time to scale up, and it's easy to find what are those steps that are required then. But what about that timeline? You just mentioned a 30 to 90 days. And again, we'll go back to I'm sure every project is different. What does it
Yes.
take to prove an ROI? That's not going to be a cookie cutter kind of solution for everybody. But is that somewhat typical, is seeing things in, as low as 30 days or 90 days? Or is this usually a process that before companies are really ready to scale up, this is a year or multiple years of data collection, analytics, and dashboards, being able to prove certain KPIs before they say, okay, now it's time to increase this project to other areas?
Yeah, it's you definitely need that time. I think 30 days is if it's a very light application and you're just coupling sensors with and you're just getting select number of data sets. However, if we use the condition monitoring as an example, I would say uh, 3 to 5 months probably is good enough. Right around 3 months, we start seeing something will start, showing, and you start seeing some trends in the uh, uh, in the graphs. So uh, other applications, it might take a little bit longer. Some other examples where we have measurement, taking some measurements for a particular part, and getting that coupled with, and it depends on the complexity of the process. It takes, we've seen it takes around 6 months just to kind of getting comfortable with it, having enough data sets in play, and then having it's these building blocks, right? As I mentioned, you're getting the connectivity, you get the visualization part, and then you start getting data. Say that's the first, couple months, it's steady, and then something started up. Then we would apply machine learning on top of it. Let it sit for like a month or two, grab all these learnings, and then meanwhile we're taking that in, we're doing the machine learning and coming back with some remedies, some adjustments on thresholds. So 4 to 6 months, at that point, I would say you would have enough data collected. People have seen it in play. It's steady. It's not impacting or jeopardizing anything. That's all proven out, giving people more comfort. And then at that point, we start having serious discussions about, okay, now this is good. It's successful. We're satisfied with it. We start putting KPIs because it's specific to that customer and to their digital journey. And then we start moving on to the how do we scale and how do we prepare for scaling it up.
And is that usually the point where you'd bring in other people into the discussion? I mean, maybe namely integrators, somebody who's
Absolutely.
best prepared
Yeah.
at that point to be able
Yes.
to help them scale up. Are there problems that come when you introduce the integration team too early, like in that pilot project? Or is it recommended to say, hey, if you have an integrator that you work with, bring them on board at the very beginning and let them know what you're up to so that they can start thinking about it? Is there a disadvantage to doing that too early?
Let's talk about the advantage if we bring them early, and that's let's use the automotive as an example. And that's and say we're introducing a digital solution that entitles vision, measurement sensors, condition monitoring, you name it, right? At that point, it's actually better off if we bring in that integrator, because now we're tapping onto their original machines. Yes, it's owned by the OEM. It's take big threes or any other car manufacturing. However, it's the when we start tapping onto that machine, onto that specific of the line, we need to go back through the end customer back onto the integrator. So it makes perfect sense to pull them in the beginning. They will be the ones that are gonna come in because it's their machine, their original machine, right? They and that's what actually the OEMs are mostly comfortable with, having the original integrator, modify to the latest and greatest settings. It's more of a recommendation, almost a must do from the direction from the OEMs themselves. There'll be times where they say, okay, we own the machine, we understand it, we have the capacity, it's a small scale, we can do it, and that's but it's more of engaging the integrator, especially if they know that they want to scale it up. So the next round, we can bring the integrator, to do their part, and even better if it's a green, a green field or a new program that can be embedded, right into the design, so it becomes naturally a part of the engineering design. So there's no need to retrofit it and all that.
Well, now that we've talked about everything from the pilot project to at least the introduction of how scaling works, could you give us just maybe one or two very short examples of how this process has looked from a small and medium company, and maybe not being able to name the companies themselves, that's that's up to privacy and of the company, but I'm just curious if you have any one or two just very short examples to share of how that looks for those medium and large companies.
Yeah, of course. With condition monitoring, in particular, the motor monitoring for vibration and temperature, right? Monitoring. We started with one of our partners. They're in the retail business and they have these distribution centers, right? Distribution warehouses. So you're talking, there's miles of conveyors that have motors to drive products from point A to point B. So what we did with this partner, we have worked on a pilot where we started with 12 motors initially, and then we let it sit for about 3 months, 3 to 4 months. During that period of time, we kind of did the fine tuning and aligned on parameters and all this. And then during that period of time, actually one of these motors we had some anomaly in it, and that's what expedited the whole process. They were able to pinpoint that particular motor and do something about it before it fails. So that was a great success. At that point, we moved on from this pilot with monitoring 12 motors onto a full distribution center with about 300 motors, and we needed to scale up, beyond the pilot. So we had to uh, come up with an architecture that can suit and apply for all these motors. And fast forward, this is like it's almost over a year, maybe a year and a half now. We're monitoring these sensors, and we started getting into more of now we're on machine learning and trying to move that up into the next level where we can predict, right, what would happen, because we have a wealth of data for the last 18 months or so. So that was the trend, and that worked out great, right? Moving from pilot onto proof of concept, pilot, onto scalability, and we're now in process of moving on to multiple sites that they want to monitor. There's 400 plus motors at each one of these sites. So that was great. Another example, it's using combination of vision and measurement sensors. We're able to pick up certain data sets and do it like a just-in-time type of thing, like within a particular phase in the process, rather than waiting toward the end of the line where it's too late. That one, we followed the same methodology. We worked on some applications with the customer. A lot of co-innovation there because they understand the process and they know what parameters they want in particular. We did a pilot for a couple applications, and that one we have used a full-blown solution where we use the sensors, the technology, so vision and measurement sensors coupled with gateways. We used our SIM controllers where we can orchestrate an interface with PLC. So now we're tabbing onto existing platforms. And then we extended beyond the pilot. We've proven all that on the control level. Now we have moved on to to scale it up. Now we've taken that data from our field analytics, our HMI interface version, and tabbing onto the customer's IT world, where we're moving that data through MQTT onto their MQTT broker, where they're able to open up ports and all that. That's a whole different thing, but we've got that rolled out. And then with that same customer, they have that, and they said they still want to keep like FTP communication protocols and such. So these two examples to kind of give you, and we had to do pilots, and we both now we're able to move on to the next level and scaling it up.
Well, those are really interesting projects to hear. I'm sure that we could continue this discussion for hours about even just these new things that you mentioned with MQTT and more of those sending things up to the cloud for analytics. But we're kind of reaching the end of our time here. And Salim, thank you so much for joining us. As we finish, we just like to finish with a couple of fun questions as time allows.
Yeah.
So right before we're done here, I'm just curious, what was your very first automation project? Robotics, automation, engineering, in your case, electrical engineering, perhaps. And was that something that was more of a hobby for fun, or was it for school, or was it actually for a real work project when you were getting started with your career?
Now you're taking me back to to some old days, but I'll answer it. I'll go back years back. So when I was like a kid, like probably 8, 10 years old, I always had this tendency of all these remote control cars, right? And some of it even had the wires, and you kind of have to follow, but at least you can move it. So when we first got those, they're nice toys. We play with them and all this. And then shortly after, maybe that first day or second day, we start breaking them apart and removing that electric motor, if you would, and start building our own. So I always had, that hobby, if you would, and maybe and then afterwards it kind of and just moved on into just normal education and all this. But then fast forward, when I landed my first job, it was working for, providing and integrating projects onto an automotive, in the automotive sector. So now it hit me, like when I was a little kid, I was playing with small toys. Now I'm a bigger kid, but I'm working with bigger toys right now, much more expensive toys.
Much more expensive.
Much more expensive, and we've seen some. There was some crashes and some faults at times. We all run into this, but it's what that taught me is that it can be fun. It just, you have to be careful with it. It's very expensive, and one small glitch and there's, but those two things I would reflect back on, and it's been satisfying with this journey, to be honest with you. Yeah.
Well, it sounds like a really incredible journey, and especially with all the projects that you've gotten to work on. And I just thank you so much for the experience that you've brought into this discussion. I know that IIoT and digital transformation is something that I have not personally been able to be involved with projects nearly as much as hardware in the past, but I'm always excited to learn and to hear from people like you with so much experience. So thank you so much for joining us for this discussion for our Control Automation Day. I really appreciate your time with us today.
I appreciate it, David. Thanks for the opportunity, and thank you so much. Appreciate it, everyone.
Once again, our sincerest thanks to SICK and to Salim for sharing his time and his experience with us today. And our special thanks to SICK for sponsoring this keynote presentation. And thank you also to our audience for joining us today for this keynote. We hope that you will be able to visit the microsites with valuable content from today's featured companies and watch the other keynotes and live sessions, all of which will be available on demand after today, so that you can also share the experience with anyone who may have been unable to join us live. Remember, the more sessions you register for today, the better your chances of winning one of our session giveaways or becoming the lucky winner of that grand prize, which, if for the first time ever, you'll have the option to choose your own prize from our list of options or even beyond. Thanks for joining us for this Control Automation Day 2025 presentation, and we look forward to seeing you again very soon.